Hello and welcome to the feedback video for Assignment 3 Forces. In this video we're going to look at the questions indicated here, and at the end of the video you'll be asked to complete a question that includes some similar concepts. You must pause the video, attempt the question and hand it back to your teacher as soon as possible. In question 1, it is asking for a scale diagram of the forces acting on Felix Baumgartner during his historic skydive in 2012. Which, if you've not heard of, please do visit one or both of the links at the bottom of the screen. The first diagram wants the forces acting on him just after he has jumped out of his capsule. As he is within the Earth's gravitational field, he will experience an attractive force towards the Earth, otherwise known as his weight. And, as he is said to be jumping from the edge of space, he is just within the Earth's atmosphere. Therefore he will also experience some resistive forces or drag. As his velocity will be low, with him only accelerating for a short time, the drag force will also be small. In the other diagram, Felix has just pulled his parachute. Obviously, he will still experience a weight or gravitational force, but his resistive force acting against his motion towards the ground has greatly increased due to him releasing his parachute. The parachute is designed to decelerate Felix from a high to a lower velocity so that he can land safely. Now in question 2, it asks you to describe fully the change in resultant force on Felix and to describe the effect on his velocity until he reaches his terminal velocity. This is when he is at a maximum constant velocity. Before he leaves his capsule, Felix has a vertical velocity of 0 meters per second. He is stationary. Once he jumps, he begins to accelerate towards the Earth. After he jumps, he begins to accelerate from 0 meters per second. As his velocity is relatively low, the drag force he experiences is also low, and therefore smaller than the gravitational force pulling him towards the Earth. If we combine these two forces acting on Felix, you can see that the resultant is quite a large force. As he falls and his velocity increases, the resistive forces acting on him also increase, and so his resultant force decreases. This will mean that his acceleration will be less. This shows us that if you include resistive forces in free-fall calculations, the acceleration would not be constant, and therefore we would not be able to use the kinematic equations for such problems. Notice that as the drag increases with his increasing velocity, his weight stays the same in both size and direction. Eventually, the drag force will equal the gravitational force, and Felix will now experience balanced forces. Balanced forces mean that the resultant force, or sum of the forces acting on him, is equal to 0, and therefore his acceleration will also be 0. He will have reached his maximum constant velocity, or terminal velocity. Here is a quick recap. If you want, you can pause the video here to check your answer. That brings us on to question 3. As we look at the diagram of the forces acting on Felix and his resultant force during his skydive, you should be able to see that the resultant force is largest at the top of his fall. This is when his velocity and resistive or drag force is the smallest. This shows that the largest rate of acceleration will be experienced here, and so when sketching the velocity time graph of this motion, the gradient which shows the acceleration should be the steepest. As the resultant force decreases, so does the rate of acceleration, and so the gradient of your graph should also get smaller or less steep, eventually showing Felix at his maximum constant speed with a flat line or zero gradient, showing that there is no acceleration. This is when weight equals drag. Right, so if you could pause the video, attempt the question that's shown, and then hand it back to your teacher as soon as possible.